Hello, in this lecture we will find the area of triangle ABC in two different ways. In the drawing we have triangle ABC with side AB of triangle ABC that equal to 8 units in size, side AC of triangle ABC equals to 14 units in size, and the angle ACB, this angle equals to x degrees in size, and angle ABC, this angle equals to 2x degrees in size, and we want to find out the area of this triangle, triangle ABC. Okay, so first of all we'll start with the first method, and we will draw line segment AD from point A in such way that it touches side BC of triangle ABC, and actually it creates angle ABC that will be equal to 2x degrees in size. Okay, so I will draw line segment AD from point A, and the touching point between line segment AD to side BC of triangle ABC is defined as point D, and angle ADB equals to 2x in size. So we draw side AD of triangle ADB in such way that angle ADB, this angle, equals to 2x degrees in size. Okay, so actually triangle ABD has two angles that are equal to each other. Those two angles in triangle ABD equals to 2x degrees in size. Okay, so in triangle ABD, there is two angles that are equal to each other, so actually angle ADB equals to angle ABD, and both those two angles are equal to 2x degrees in size. Okay, so in triangle ABD, angle ADB equals to angle ABD, and both those two angles are equal to 2x degrees in size. So actually we have a rule number 1 that states that in front of equal angles in the triangle, there are equal sides. So I will read rule number 1 again. Rule number 1 states that in front of equal angles in the triangle there are equal sides. So actually, if we have triangle ABC, that can be any triangle, not necessarily our triangle ABC, but any other triangle, and in triangle ABC we have two equal angles. In this triangle ABC, we have two equal angles. This angle equals to alpha, and this angle also equals to alpha. Then, according to rule number 1, in front of equal angles there are equal sides. So in front of this angle alpha we have side AB, and in front of this angle alpha we have side AC. So according to rule number 1, the sides that are located in front of equal angles are also equal to each other. That is to say, AB equals to AC. Okay, so I will repeat again on rule number 1. If we have triangle ABC, that can be any triangle, that has two equal angles, that is to say those two angles are equal to each other, both of those two angles are equal to angle alpha, then according to rule number 1, in front of equal angles there are equal sides. In front of this angle alpha we have side AC, and in front of this angle alpha we have side AB, and according to rule number 1, the sides that are located in front of equal angles are also equal to each other. That is to say, AB equals to AC. Okay? The sides that are located in front of equal angles, that is to say side AB and side AC, are also equal between them. That is to say AB equals to AC. Okay? So actually we can implement rule number 1 in our triangle ABD. Triangle ABD has two equal angles again. Triangle ABD, this triangle has two equal angles. Angle ADB is equal to angle ABD, and both those two angles are equal to 2x degrees in size. Again, triangle ABD has two equal angles, that is to say angle ABD equals to angle ADB equals to angle ABD. Both of those two angles are equal to 2x degrees in size. Therefore, according to rule number 1, the sides that are located in front of those two equal angles are also equal to each other. That is to say, in front of this angle 2x, we have side AB, this side, and in front of this angle 2x, we have side AD. So according to rule number 1, the sides that are located in front of those two equal angles are also equal to each other. That is to say AB equals to AD. Okay, so according to rule number 1, side AB of triangle ABD equals to side AD. Okay, side AB of triangle ABD equals to side AD. Okay, side AB equals to side AD according to rule number 1, but we know that side AB equals to 8 units. Side AB equals to 8 units in size. So we can write here that AB equals to 8 units in size, So from this equality we can derive that AD also equals to 8 units. Okay, AD equals to 8 units in size. Okay, AD equals to 8 units in size, so actually this side AD equals to 8 units in size. In the next step I will present to you a new rule number 2, but before I present you rule number 2, I will explain to you what is exterior angle and what are interior angles. Okay, so actually if we have triangle ABC, that can be any triangle, not necessarily our triangle ABC, but any other triangle. Okay, this triangle ABC has 3 interior angles: angle alpha, angle beta, and angle gamma are defined as interior angles. Okay, those two angles are defined as interior angles. And actually angle ABL, this angle is defined as exterior angle. Again, we have inside triangle ABC 3 interior angles: angle alpha, angle beta, and angle gamma are defined as interior angles, and angle ABL that is located outside of triangle ABC is defined as exterior angle. But we know that angle gamma is located in the opposite sides of angle alpha and beta. So angles alpha and beta are also defined as opposite interior angles because they are located in opposite sides in relation to angle gamma. So angles alpha and beta are defined as opposite interior angles. Okay, so those two angles, angle alpha and beta, are defined as opposite interior angles because they are located in opposite sides in relation to angle gamma. And angle ABL, this angle is defined as exterior angle. Okay, so that is the definition of interior angle and the definition of exterior angles. Okay, so now I will present to you rule number 2. Rule number 2 states that the exterior angle ABL in this example the exterior angle of a triangle this angle is equal to the sum of the two opposite interior angles. The two opposite interior angles. In our example, the two opposite interior angles are angles alpha and beta, so actually, according to rule number 2, the size of an angle ABL, that is the exterior angle in this drawing, the size of angle ABL is equal to the sum of the two angles, the two opposite interior angles, that is to say, is equal to alpha plus beta. Again, I will read rule number 2 again. According to rule number 2, the exterior angle of a triangle, that is to say, in our example, angle ABL, is equal to the sum of the two opposite interior angles. Okay, of the two opposite interior angles. So I'll read rule number 2 again. Rule number 2 states that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. Okay, so actually the exterior angle, angle ABL, is equal to the sum of the two opposite interior angles. That is to say, it equals to alpha plus beta. Angle ABL, that is defined as the exterior angle in relation to triangle ABC, is equal to the sum of the two opposite interior angles. That is to say, angle ABL equals to angle alpha plus angle beta. Okay, again the exterior angle, angle ABL equals to angle alpha plus angle beta. That is according to rule number 2. And again, we can implement rule number 2 in our drawing. Actually, we have triangle ADC and triangle ADC has two opposite interior angles. Those two angles are defined as opposite interior angles, and angle ADB, this angle that equals to 2x degrees in size, is defined as exterior angle of triangle ADC. So according to rule number 2, the exterior angle, angle ADB, that equals to 2x in size, 2x degrees in size, equals to the sum of the two opposite interior angles. That is to say, it equals to angle DAC plus angle ACD. Again, according to rule number 2, the exterior angle that equals to 2x equals to the sum of the two interior angles of triangle ADC. The two opposite interior angles of triangle ADC are actually angle DAC and angle ACD, so the sum of those two angles, angle DAC plus angle ACD, equals to the exterior angle, angle ADB, that equals to 2x degrees in size, according to rule number 2. But what is the value of angle ACD? Angle ACD, this angle equals to x degrees in size. It is given us in the question, so we can substitute angle ACD by x, because angle ACD equals to x degrees in size, and we will get that 2x equals to angle DAC plus angle ACD that equals to x degrees in size. So we got this equality that states that 2x plus angle DAC two x equals to angle DAC plus x. I substituted angle DAC by x and we got the equality that states that 2x equals to angle DAC plus x. So from this equality we will subtract x and we will get that two x minus x equals to x, and in the other side of the equation we have angle DAC plus x minus x, so angle DAC equals to x degrees in size. We got the equality that states that angle DAC equals to x degrees in size. So actually this angle DAC also equals to x degrees in size. Okay, so actually in triangle DAC, this triangle, we have two angles that are equal to each other. In triangle DAC, this triangle angle DAC is equal to angle ACD. Both those two angles are equal to alpha. And again in triangle TAC, we have two angles that are equal to each other. Angle DAC equals to angle ACD. Both those two angles are equal to alpha. Both those two angles are equal to x. And again in triangle ADC, we have two angles that are equal to each other. Both those two angles are equal to x degrees in size. Again in triangle ADC, angle DAC is equal to angle ACD. Both those two angles are equal to x degrees in size. So we can implement rule number 1 in this triangle. According to rule number 1, in front of equal angles there are equal sides. So in front of this angle x, we have side DC of triangle ADC, and in front of this angle x, we have side AD of triangle ADC. So according to rule number 1, the sides that are located in front of equal angles are also equal to each other. That is to say, AD equals to DC, AD equals to DC in triangle DAC according to rule number 1. Again, those two sides side AD and side DC are located in front of equal angles, therefore they are also equal to each other. That is to say, AD equals to DC according to rule number 1, but we have already found out that AD equals to 8 units in size. AD equals to 8 units in size. So from this equality we can deduce that DC also equals to 8 units in size. Okay, DC equals to 8 units in size. So this side of triangle ADC equals to 8 units in size. Okay, side DC of triangle ADC equals to 8 units in size. So in the next step I will present to you rule number 3 that relates to isosceles triangle. Before that, I will explain you what is the base of an isosceles triangle. If we have an isosceles triangle, triangle ABC, so if triangle ABC is an isosceles triangle, this triangle, that is to say AB equals to AC, we know that AB equals to AC, therefore triangle ABC is an isosceles triangle. Then the base of triangle ABC is defined as BC. Okay, BC is the base of triangle ABC. Again, we know that AB equals to AC, therefore triangle ABC is an isosceles triangle. So the base of the isosceles triangle ABC is defined as side BC of triangle ABC. So now I will present to you rule number 3. Rule number 3 states that the height to the base in an isosceles triangle divide the base into two equal parts. So I will read rule number 3 again. Rule number 3 states that the height to the base in an isosceles triangle divides the base into two equal parts. So actually, in this isosceles triangle, triangle ABC, if from point A we will draw height to the base BC, the height to the base BC, first of all, the height creates 90 degrees with the base BC, that is to say this angle is a right angle, and this angle also equals to 90 degrees in size, and we will define the touching point between the height to side BC of triangle ABC as point D. Again, point D is the touching point between the height the red line is the height to the base. Okay, so the height AD to the base divide the base BC to two equal parts, that is to say BD equals to DC according to rule number 3. Okay, BD equals to AC, that is according to rule number 3. So I will repeat on rule number 3 again. If we have isosceles triangle, triangle ABC, that is to say AB equals to AC, so triangle ABC has two equal sides, therefore it is an isosceles triangle. And if from point A we draw a height to the base BC, then that height divides the base BC to two equal parts, that is to say BD equals to DC. Okay, according to rule number 3, BD equals to DC. Okay, those two line segments are equal to each other, BD equals to DC. So again, we can implement rule number 3 in our drawing, because we have triangle ABD is an isosceles triangle because side AB of triangle ABD equals to side AD. Okay, side AB in triangle ABD side AB equals to side AD. AB equals to AD, therefore AB equals to AD in triangle ABD, therefore triangle ABD is an isosceles triangle. Okay, triangle ABD is an isosceles triangle because of the fact that side AB of triangle ABD equals to side AD. So now if we withdraw from point A height to the base BD of triangle ABD, of the isosceles triangle ABD, we define the height to the base as h, and we will define the touching point between the height h to the base BD as point E. Again, point E is the touching point between the height h to the base BD. Then, according to rule number 3, the height AE that equals to h divide the base BD to two equal parts. That is to say, BE equals to ED. Again, according to rule number 3, the height h divide the base BD to two equal parts. That is to say, BE equals to ED. Okay, so according to rule number 3, BE equals to ED because the height h divides the base BE to two equal parts. That is to say, BE equals to ED. And if we define BE as A, that is to say, if BE equals to A, according to our definition, if BE equals to A, then from this equality we can derive that ED also equals to A. ED also equals to A. So ED equals to A units in size. And again, the height always creates 90 degrees if the base, that is to say, this angle is a right angle, it equals to 90 degrees, and this angle is also a right angle, that is to say, it equals to 90 degrees. Angle AED is a right angle, it equals to 90 degrees, and angle AEB, this angle is also equals to 90 degrees in size. Okay? So, in the next step, we will focus on triangle ABE. Actually, this green triangle, triangle ABE, is a right triangle because of the fact that angle AEB equals to 90 degrees. So, in triangle ABE, the green triangle, triangle ABE, angle AEB equals to 90 degrees in size. Integrate triangle AEB. Angle AEB equals to 90 degrees in size. Therefore, triangle AEB is a right triangle. Therefore, triangle ABE is a right triangle. Okay, integrate triangle ABE, angle AEB equals to 90 degrees. Therefore, integrate triangle ABE is a right triangle. So we actually can implement the Pythagorean theorem in the right great triangle ABE. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB is the hypotenuse of the great right triangle ABE. Therefore, AB squared equals to the sum of the squares of the perpendiculars equals to BE squared plus AE squared. So according to the Pythagorean theorem, the square of the hypotenuse in the right great triangle ABE equals to the sum of the squares of the perpendiculars equals to BE squared plus AE squared. Okay. In the right great triangle ABE, according to the Pythagorean theorem, the square of the hypotenuse, that is to say AB squared, equals to the sum of the squares of the perpendiculars equals to BE squared plus AE squared. Okay, but what is the value of AB? AB equals to 8 units in size because it is given us in the question. So AE squared will be equal to 8 squared, that is 64, equals to BE squared. BE is A. According to our definition, BE equals to A, so BE squared is A squared plus AE squared. AE equals to H, so AE squared equals to H squared. So in total, we got the question number 1 that states that 64 equals to A squared plus H squared. So here we will subtract from equation number 1 A squared, and we will get equation number 1 that states that H squared equals to 64 minus A squared. Okay, so according to equation number 1, here we subtracted A squared from this equation number 1 and we got that H squared equals to 64 minus A squared. Okay, so actually we have here another right triangle, but triangle AEC is also a right triangle because this angle is a right angle. So actually the orange triangle the orange triangle AEC is a right triangle because of the fact that angle AEC equals to 90 degrees. So I write it down that the orange triangle AEC is a right triangle because angle AEC is a right angle. Okay, this angle AEC equals to 90 degrees, therefore the orange triangle AEC is a right triangle. Okay, the orange triangle AEC is a right triangle because angle AEC is a right angle. It equals to 90 degrees in size. Therefore, we can implement the Pythagorean theorem on the orange right triangle AEC, and according to the Pythagorean theorem, the square of the hypotenuse in the right main triangle is AC, so it is AC square equals to the sum of the squares of the perpendiculars equals to AE square plus EC square. Again, according to the Pythagorean theorem, in the right triangle AEC, the square of the hypotenuse, that is AC square, equals to the sum of the squares of the perpendiculars equals to AE square plus EC square. Okay, AC square equals to AE square plus EC square or CE square, it is the same. So what is the value of AC? AC equals to 14 units in size, so AC square is 14 square, and 14 square is 196 equals to AE square. AE equals to H, so AE square is H square plus EC square. What is the value of EC? EC equals to A plus 8. Again, EC equals to A plus 8. So EC square is A plus 8 square. So in total, we got equation number 2 that states that 196 equals to 8 square plus A plus 8 square. But we have already found out that in question number 1 that 8 square equals to 64 minus A square. So we actually can substitute 8 square in equation number 2 by 64 minus a squared, because a squared equals to 64 minus a squared. So we'll do it now. We'll substitute a squared in equation number 2 by 64 minus a squared. Okay, so we will get that 196 equals to 64 minus a squared plus a plus 8 squared is actually a squared plus 8 squared is 64 plus 2 times a plus 8 is 16a. So in total we got that 196 equals to 64 minus a squared plus a squared is 0, so a squared is cancelled, plus 64 plus 16a. So 64 plus 64 is 128, so I'll write it down. So we got that 196 equals to 64 plus 64 is 128 plus 16a. So in total we got equation number 2 that states that 196 equals to 128 plus 16a. Here we will subtract 128 from this equation number 2 and we will get that 196 minus 128 is 68 equals to 16a. So we got that equation number 2 states that 68 equals to 16a. So here we will divide equation number 2 by 16 in order to get the value of a. Okay, we will divide equation number 2 by 16 in order to get the value of a. We will get that a equals to 68 over 16. So we found out that a equals to 68 over 16. Here we can divide the numerator and the denominator by 4. 16 over 4 is 17 and 16 over 4, 68 over 4 is 17 and 16 over 4 is 4. So in total we will get that a equals to 17 over 4. So actually the value of a is 17 over 4 units. So we found out the value of a. A equals to 17 over 4 units. And we also have equation number 1 that states that x squared equals to 64 minus a squared okay, h squared according to equation number 1, h squared equals to 64 minus a squared. So here we will square this equality in order to get the value of a squared. If we square this equality, we will get that a squared equals to 17 squared, that is 289, over 4 squared, that is 16. So the value of a squared according to equation number 2, a squared equals to 289 over 16. Okay, a squared equals to 289 over 16. So here we can substitute the value of a squared that equals to 289 over 16, or we can substitute a squared in equation number 1 by 289 over 16 equals a squared equals to 289 over 16. So we will get that h squared equals to 264 minus 289 over 16. Okay, we substituted a squared in equation number 1 by 289 over 16, and we got that h squared equals to 64 minus 289 over 16. So here we will multiply 64 by 16, and then we will divide it by 16 in order to have a common factor with this number. So we will get that h squared equals to 64 times 16 is 1024 minus 289 over 16. So in total we got that h squared equals to 1024 minus 289 over 16. Here 1024 minus 289 equals to 735. So I write it down. H squared equals to 735 over 16. So here we will take a root out of this equality in order to get the value of h. So we will get that h equals to the root of 735 over 16. Okay, and 735 equals to 15 times 7 times 7, and 16 equals to 4 times 4. So in total we got that h equals to the root of 15 times 7 times 7 over 4 times 4. The root of 7 times 7 is 7, and the root of 4 times 4 is 4. So we can take out 7 over 4 from the root. We can take 7 over 4 out of the root. So we will get that h equals to, we take 7 over 4 out of the root. So what is left inside the root is only 15. So we found out that the value of h, that is the height of triangle ABC, equals to 7/4 times root 15 units. And we've already found out that A equals to 17/4 units. So actually we found out the values of H and A. But what is the area of any triangle? The area of any triangle, A is the abbreviation for area. The area of any triangle equals to the base of the triangle times the height to the base over 2. So the area of any triangle equals to the formula for the area of any triangle equals to the base of the triangle times the height to the base over 2. You should remember that the height must create 90 degrees with the base, otherwise it is not the height. Okay, so what is the area of our triangle ABC? The area of triangle ABC equals to the base of the triangle, that is BC, the base BC times the height to the base. The height must create 90 degrees with the base, and indeed AE that equals to H creates 90 degrees with the base BC. This angle is 90 degrees and this angle is also a right angle. So the height of triangle ABC is H. Okay, so it is the base BC times the height, that is H, over 2. So the area of triangle ABC equals to the base BC times the height, that is H, over 2. We have already found out the value of H. H equals to 7/4 times root 15 units. So we actually can substitute H by 7/4 times root 15. So the area of triangle ABC equals to the base BC times the height, that equals to 7/4 times root 15, all divided by 2. In total we got that the area of triangle ABC equals to BC times 4/root 15. 4 times 2 is 8, so I write it down. The area of triangle ABC equals to BC, that is the base of the triangle, times 7 times root 15 over 4 times 2 is 8. So in total we got that the area of triangle ABC equals to BC times 7 times root 15 over 8. But what is the value of BC? BC equals to A plus A plus 8. Again, BC equals to A plus A plus 8. So BC equals to 2A plus 8. So the area of triangle ABC equals to 2A, BC that equals to 2A plus 8 times root 15 times 7 over 8. So in total we got that the area of triangle ABC equals to 2A plus 8 times root 15 times 7 over 8. But we have already found out that A equals to 17 over 4 units, so we can substitute A here by 17 over 4 units. So 17 over 4 times 2 is 17 over 2, so I write it down. In total we got that the area of triangle ABC equals to 17 over 2 plus 8 times root 15 times 7 over 8. Okay, so the area of triangle ABC equals to 17 17 over 2 plus 8 So actually the area of triangle ABC equals to 17 over 2 plus 8 times root 15 times 7 over 2. Okay, the area of triangle ABC equals to 17 over 2 plus 8 times root 15 times 7 over 2. Here we'll substitute 8 by 16 over 2 in order to have a common factor with this number. So we'll get that the area of triangle ABC equals to 17 over 2 plus 16 over 2 times root 15 times 7 over 2. So we got that the area of triangle ABC equals to 17 plus 16 over 2 times root 15 times 7 over 2. So the area of triangle ABC equals to 17 plus 16 is 33 over 2 times 7 times root 15 So the area of triangle ABC equals to 17 over 2 plus 16 over 2 times root 15 times 7 over 2. So here we have all divided by 8. So the area of triangle ABC equals to 17 plus 16 over 2 times root 15 times 7 over 8. So the area of triangle ABC equals to 33 times 7 times root 15 over 8 times 2. 33 times 7 is 231, and 8 times 2 is 16. So the area of triangle ABC equals to root 15 times 231 over 16 square units. So we found out that the area of triangle ABC equals to root 15 times 231 over 16 square units. Okay, so in the next step I will present to you second method to find out the area of triangle ABC. Okay. So in the second method we'll first of all find the size of angle A. We know that the sum of the angles in any triangle is equal to 180 degrees, so angle A plus angle B plus angle C must be equal to 180 degrees. Okay, the sum of the angles in any triangle equals to 180 degrees. Therefore, angle A plus angle B plus angle C must be equal to 180 degrees. So angle A plus angle B equals to 2x, and angle C equals to x. So in total we got that angle A plus 2x plus x equals to 180 degrees. So 2x plus x equals to 3x. So angle A equals to 3x. Angle A plus 3x equals to 180 degrees. So here angle A plus 3x equals to 180 degrees. Here we will subtract 3x from this equality in order to get the value of angle A, and we will get that the value of angle A equals to 180 degrees minus 3x. So we found out that the value of angle A is actually 180 degrees minus 3x. So we can write here that angle A equals to 180 degrees minus 3x. So in the next step I will present you a new formula for the area of any triangle. That will be rule number 4. So according to rule number 4, if we have triangle ABC, that could be any triangle, not necessarily our triangle but any other triangle, and we know that the size of side AB of triangle ABC equals to A units, and side AC of triangle ABC equals to B units in size. And we also know that the angle between side AB and side AC of triangle ABC equals to theta. Then the area of this triangle ABC, according to the new formula, equals to A times B times sinus theta over 2. So the area of any triangle ABC can be any triangle, the area equals to A times B times sinus theta over 2. So we actually can implement the rule number 4 in our triangle ABC, and we will find the area of our triangle ABC according to the new formula. So the area of triangle ABC according to the new formula will be AB times AC times sinus 180 degrees minus 3x over 2. Okay, so the area of triangle ABC will be equal to AB times AC times sine of 180 degrees minus 3x over 2. So according to new formula, rule number 4, the area of our triangle ABC equals to AB times AC times sine of 180 degrees minus 3x over 2. Okay, but what is the value of AB? The value of AB equals to 8 units in size, and what is the value of AC? AC equals to 14 units in size times sine of 180 degrees minus 3x over 2. So the area of triangle ABC equals to AB, that is 8 units, times AC, that is 14 units, times sine of 180 degrees minus 3x over 2. Here 14 over 2 is 7, and 7 times 8 is 56. So in total we will get that the area, this is our first equation, the area of triangle ABC equals to 56 times sine of 180 degrees minus 3x. Okay, so the area of triangle ABC equals to 56 times sine of 180 degrees minus 3x. Now we have trigonometric identity that states that the sine of 180 degrees minus alpha equals to the sine of alpha Okay, we'll use this trigonometric identity that states that the sine of 180 degrees minus alpha equals to sine alpha. So according to this trigonometric identity, the sine of 180 degrees minus 3x will be equal to sine 3x. Okay, so the area of triangle ABC will be equal to 56 times sine of 3x. Okay, so equation number 1 states that the area of triangle ABC equals to 56 times sine 3x. So in the next step I will present you a new rule, rule number 1 and rule number 5, and we will use rule number 5 in our triangle. Actually, rule number 5 is the law of sines. Actually, you can use the law of sines in any triangle. So, in any triangle, if we have any triangle ABC that is not necessarily our triangle but any other triangle, we know that the size of side BC of triangle ABC equals to A units, and the size of side AC of triangle ABC equals to B units, and the size of side AB of triangle ABC equals to 3 units. Then, according to the law of sines, A over sinus A actually capital A is the size of this angle, equals to B over sine B. Again, capital B is the size of this angle, equals to C over sine C. And again, capital C is the size of this angle. So, according to the law of sines, in any triangle, A over the sine of this angle equals to B over the sine of this angle equals to C over sine of this angle. Okay, so we actually can implement the law of sines in our triangle ABC. So, in our triangle, according to the law of sines, AB over sine X equals to AC over sine 2X. Again, according to the law of sines, in our triangle ABC, AB over sine X equals to AC over sine 2X. Okay, AB over sine X equals to AC over sine 2X. But what is the value of AB? AB equals to 8 units. So 8 over sine X equals to AC. The value of AC is 14 units, so it is 14 over sine 2X. So in total we got that 8 over sine X equals to 14 over sine 2X. We actually have trigonometric identity for sine 2X. Sine 2X equals to 2 sine X cosine X. So we actually can substitute sine 2X by 2 sine X cosine X. So we'll do it now. 8 over sine X equals to 14 over 2 sine X cosine X. So here we have sine X in the denominator, and we have sine X in the denominator of the other side of the equality, so we can cancel sine X, and 14 over 2 is 7, so in total we will get that 7 over cosine x equals to 8. So we got that 7 over cosine x equals to 8. Here we will multiply the identity by cosine x and then we will divide it by 8. We will get that cosine x equals to 7 over 8. Okay, we got that cosine x equals to 7 over 8. In the next step I will present you trigonometric identity and from the trigonometric identity we will find out the value of sine x. The trigonometric identity states that sine of square x plus cosine of square x equals to 1. So sine square x plus cosine square x equals to 1. So from this trigonometric identity we will subtract cosine square x and we will get that sine square x equals to 1 minus cosine square x. So from this equality we will take a root from this equality and we will get that sine x equals to the root of 1 minus cosine square x so we found out that the value of sine x is actually the root of 1 minus cosine square x. Here we found out that the value of cosine x equals to 7 over 8, so if we square this equality we will get the value of cosine square x. So if we square this equality we will get that cosine square x equals to 49 over 64. Okay, so cosine square x equals to 49 over 64. So here we can substitute cosine square x by 49 over 64 and we will get that sine x equals to the root of 1 minus we substitute cosine x by 49 over 64. So we got that sine x equals to the root of 1 minus 49 over 64. Here we will substitute 1 by 64 with this 64 in order to have a common factor with this number. We get that sine x equals to 64 minus 49 over 64 only in the root. So here 64 minus 49 is 15 and the root of 64 is 8, so in total we will get that sine x equals to root 15 over 8. So we found out that sine x equals to root 15 over 8. In the next step, we will return to our equation number 1. In equation number 1, we found out that the area of triangle ABC equals to 56 times sine 3x. Okay, we have already found out that according to equation number 1, the area of triangle ABC equals to 56 times sine 3x. Actually, we have trigonometric identity for the value of sine 3x. Sine 3x equals to 3 sine x minus 4 sine cube x. Okay, the trigonometric identity states that sine 3x equals to 3 sine x minus 4 sine cube x. So we will substitute sine x by this expression, and we will get that the area of triangle ABC equals to 56, and instead of sine 3x we will write this expression that equals to sine 3x, 3 sine x minus 4 sine cube x. Okay, so we found that the area of triangle ABC equals to 56 times 3 sine x minus 4 sine cube x. Here we will take sine x as a common factor of this expression, and we will get that the area of triangle ABC equals to 56, and sine x is a common factor of this expression. So inside the brackets, what is left is 3 minus 4 sine square x. Okay, so the area of triangle ABC equals to 56 times sine x times 3 minus 4 sine square x. We have already found out that sine x equals to root 15 over 8. So here we will square this equality in order to get the value of sine square x. So sine square x will be equal to the root 15 times root 15 is 15, and 8 square is 64. So we found out that sine square x equals to 15 over 64. So the only thing that is left now is to substitute sine x by root 15 over 8, and to substitute sine square x by 15 over 64. So we get that the area of triangle ABC equals to 56 and instead of sine x we substitute sine x by root 15 over 8, and in the brackets we have 3 minus 4 times sine square x. We will substitute sine square x by 15 over 64. So in total we got that the area of triangle ABC equals to 56 times root 15 over 8. In the brackets we have 3 minus 4 times root 15 over 64. Here 56 over 8 is 7, and here we will cancel 4. We'll divide the numerator and the denominator by 4. We get here 4 will be cancelled, and 64 over 4 is 16. So in total we will get that the area of triangle ABC equals to 7 times root 15, 3 minus 15 over 16. So here we will substitute 3 by 84 over 16 in order to have a common factor with this number. So we will get that the area of triangle ABC equals to root 15 times 7, and we will substitute 3 by 84 over 16. So the area of triangle ABC equals to root 15 times 7. 84 minus 15 is 33 over 16. Okay, so the area of triangle ABC equals to root 15. 48 minus 15 is 33 over 16. So the area of triangle ABC equals to root 15 times 7 times 33 over 16. 7 times 33 is 231. So the total answer to the question is that the area of triangle ABC equals to root 15 times 231 over 16 square units. Again, the area of triangle ABC equals to root 15 times 231 over 16 square units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the area of triangle ABC. We know that side AC of triangle ABC equals to 14 units, side AB equals to 8 units. This angle is x and this angle is 2x, and we want to find out the area of triangle ABC. Okay, so first of all, made a construction from point A. We draw a straight line to side BC of triangle ABC until it touches side BC at point D in such a way. We constructed 9 segment AD in such a way that angle ADB, this angle equals to 2x in size. So in triangle ABD we have two angles that are equal to each other. Both those two angles are equal to 2x, okay? So in triangle ABD we have two angles that are equal to each other. Angle ADB equals to angle ABD equals to 2x degrees in size. And we have rule number 1 that states that in front of equal angles in a triangle there are equal sides. So if we have triangle ABC that has two equal angles, that is to say those two angles are equal to each other, both those two angles are equal to alpha, then according to rule number 1, in front of equal angles there are equal sides. That is to say, in front of this angle alpha we have side AC, and in front of this angle alpha we have side AB. So according to rule number 1, the sides that are in front of equal angles are also equal to each other. That is to say, side AB equals to side AC. Okay, in front of equal angles we have equal sides. That is to say, AB equals to AC. Okay, so we actually can implement rule number 1 in our triangle ABD. In this triangle we have two angles that are equal to each other. So according to rule number 1, in front of equal angles we have equal sides. So in front of this angle 2x we have side AD of triangle ADB, and in front of this angle 2x we have side AB of triangle ADB. So according to rule number 1, in front of equal angles there are equal sides. That is to say, AB equals to AD. Okay, AB equals to AD. According to rule number 1, AB equals to AD. Okay, because in front of equal angles we have equal sides, so that is to say AB equals to AD. But we know that AB equals to 8 units. AB equals to 8 units, so from this equality we can deduce that AD also equals to 8. From this equality we can deduce that AD equals to 8 units. AD equals to 8 units in size. And then I presented to you rule number 2 that talks about exterior angle and interior angles. Actually in triangle ABC those two angles are defined as opposite interior angles, and this angle is defined as exterior angle. And according to rule number 2, the exterior angle of a triangle is equal to the sum of the two opposite interior angles. That is to say, the exterior angle, this angle ABL, is equal to the sum of the two exterior angles that are actually alpha plus beta, or in other words, angle ABL equals to angle alpha plus angle beta. Again, the exterior angle ABL equals to the sum of the two opposite interior angles. That is to say, angle ABL equals to angle alpha plus angle beta. Angle ABL equals to angle alpha plus angle beta according to rule number 2. And again, we can implement rule number 2 in our drawing. We have triangle ADC. The orange triangle ADC, has two interior opposite interior angles. Okay, triangle DAC. This triangle DAC. We have two opposite interior angles, angle DAC and angle ACD are two opposite interior angles, while angle ADB that equals to 2x is the exterior angle. So according to rule number 2, the exterior angle that equals to 2x will be equal to the sum of those two angles, or the exterior angle 2x will be equal to angle DAB plus angle ACD. Okay, the exterior angle that equals to 2x will be equal to angle DAC plus angle ACD. But we know that angle ACD equals to x degrees, so we can substitute angle ACD by x, and we will get the 2x equals to angle ACD plus x. Here we will subtract x from this equality, and we will get that the size of angle DAC is x. So this angle DAC equals to x. So actually we have in triangle DAC two angles that are equal to each other, and according to rule number 1, in front of equal angles there are equal sides. So in front of this angle x, we have side DC, and in front of this angle x, we have side AD, and according to rule number 1, in front of equal angles there are equal sides, that is to say AD equals to DC. Again, according to rule number 1, in triangle ADC we have two equal angles, therefore according to rule number 1, in front of equal angles there are equal sides, that is to say AD equals to DC. AD equals to DC. But we know that AD equals to 8 units in size. AD equals to 8 units in size, so from this equality we can derive that DC also equals to 8 units. Okay, DC also equals to 8 units, so DC equals to 8 units. And then I presented to you rule number 3 that talks about an isosceles triangle. If we have isosceles triangle ABC, that is to say it has two sides that are equal to each other, AB equals to AC, and the base of an isosceles triangle is this BC. The base of this line triangle is side BC of the triangle. So rule number 3 states that the height to the base in an isosceles triangle divides the base into two equal parts. So according to rule number 3, the height in the red color, the line in the red color, the height to the base, the height to BC divides the base BC to two equal parts, that is to say BD equals to DC. So according to rule number 3, BD equals to DC, and the height to the base gets 90 degrees with the base, so this angle is 90 degrees and this angle is also 90 degrees. So the height to the base divides the base BC to two equal parts, that is to say BD equals to DC. Okay, so we actually can implement rule number 3 in our triangle. We have triangle ABD, this triangle that has It is a right triangle because AB equals to AD. It is an isosceles triangle. Triangle ABD is an isosceles triangle because side AB equals to side AD. So according to rule number 3, if we draw a height to the base BD, then that height will divide the base BD to two equal parts, that is to say BE equals to ED. Again, in the isosceles triangle ABD, if we draw height to the base BD, then that height will divide the base to two equal parts, that is to say BE equals to ED. And then if we will define BE as A, that is to say BE equals to A, if B equals to A, then according to this equality we can deduce that ED also equals to A, ED equals to A. So actually the green triangle ABE is a right triangle because this angle AEB equals to 90 degrees. So in the green right triangle we can implement the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say AB square equals to BE square plus AE square. Again, in the right green triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AB square equals to BE square plus AE square. But we know that AB equals to 8 units, so AB square is 64, and BE equals to A, so BE square is A square, and AE equals to H, so AE square equals to H square. So from equation number 1 we got that H square equals to 64 minus A square, and then the orange triangle AEC is also a right triangle because it has this angle that equals to 90 degrees. Therefore the orange triangle AEC is a right triangle, so we can implement the Pythagorean theorem in the orange right triangle AEC. According to the Pythagorean theorem, the square of the hypotenuse, that is to say AC square, equals to the sum of the squares of the perpendiculars equals to AE square plus EC square. Okay, according to the Pythagorean theorem, in the right orange triangle, the square of the hypotenuse, that is to say AC square, equals to the sum of the squares of the perpendiculars equals to AE square plus EC square. And we know that AC equals to 14 units in size, so AC square is 14 square, that is 196. AE equals to H according to our definition, so AE square is H square, and EC equals to A plus 8. Again, EC equals to A plus 8, so EC square is A plus 8 square. So in total we got that 196 equals to H square plus A plus 8 square. Okay, but we found out in equation number 1 that H square equals to 64 minus A square. So we can substitute H square in equation number 2 by 64 minus A square. So we substituted H square by 64 minus A square. So we have in equation number 2 only one variable that is missing, that is A. So we solved the equation number 2 and we found out that A equals to 17 over 4 units. And then we have equation number 1 that states that H square equals to 64 minus A square. And if A equals to 16 over 4, then A square will be equal to 289 over 16. So we can substitute A square by 289 over 16 in equation number 1. So we substituted A square by 289 over 16. So we have only one variable that is missing, that is age. After solving the equation number 1, we found out that age equals to 7/4 times root 15 units, and we have already found out that A equals to 17/4 units. So we know that the area of any triangle equals to the base of the triangle times the height to the base over 2. The height must create 90 degrees with the base. So the area of triangle ABC will be equal to the base of the triangle, that is BC, times the height to the base, that is AE, edge, that equals to edge, and the height edge creates 90 degrees with the base BC, so edge is the height of triangle ABC, so it is the base BC times the height edge over 2. So the area of triangle ABC equals to the base BC times the height, that is edge over 2, and we have already found out that edge equals to 7/4 times root 15, so we substituted edge in this equality by 17/4 times root 15, all divided by 2. And what is the value of BC? BC equals to A plus 8, so BC equals to 2A plus 8. So BC equals to 2A plus 8, so we substituted BC by 2A plus 8, but we have already found out that A equals to 17/4 units. So we can substitute A by 17/4 units. Okay, so actually we have all the values of the variables in this equality. So we found out that the area of triangle ABC equals to root 15 times 231/16 square units. That was the first method to find out the area of triangle ABC. Then we found out the area of triangle ABC in a second method. In this method, we first of all found the size of angle A according to the law that the sum of the angles in any triangle equals to 180 degrees. So angle A plus angle B plus angle C of triangle ABC equals to 180 degrees, but angle B equals to 2x and angle C equals to x. So in total we got that the size of angle A equals to 180 degrees minus 3x. The size of angle A equals to 180 degrees minus 3x. And then I presented to you a new formula to find the area of any triangle. For the area of any triangle, the area of any triangle according to the new formula equals to A times B times sinus theta over 2. Okay, and we use this formula in order to find out the area of our triangle ABC. According to the new formula, the area of triangle ABC will be equal to AB times AC times sinus 180 degrees minus 3x over 2. Okay, the area of triangle ABC equals to AB times AC times sinus 180 degrees minus 3x over 2. But we know that AB equals to 8 units, AC equals to 14 units, so AB equals to 8 units, AC equals to 14 units. So the area of triangle ABC equals to 56 times sine of 180 degrees minus 3x. And we have the trigonometric identity that states that sine of 180 degrees minus alpha equals to sine alpha. So according to this trigonometric identity, sine of 180 degrees minus 3x equals to sine 3x. So the area of triangle ABC will be equal to 56 times sine 3x. So that is equation number 1. Then I presented to you rule number 5, that is actually the law of sines. According to the law of sines, A over sinus A equals to B over sinus B equals to C over sinus C, and capital A, capital B, and capital C are the sizes of angles ABC. So we can use this equality in any triangle, and especially in our triangle ABC. So according to the law of sines, in our triangle ABC, AB over sinus x equals to AC over sine 2x. Okay, according to the law of sines, AB over sine x equals to AC over sine 2x. But we know that AB equals to 8 units, AC equals to 14 units, so we'll substitute AB by 8 and AC by 14. And we have the trigonometric identity for sine 2x. Sine 2x equals to 2 sine x cosine x, so we can substitute sine x by 2 sine x cosine x. So here we cancel sine x because we have sine x in both sides of the equation. And then we found out that cosine x equals to 7 over 8. Then I presented to you new trigonometric identity that sine square x plus cosine square x equals to 1. From this trigonometric identity we found out that sine x equals to the root of 1 minus cosine square x. And we know that cosine square x equals to 7 over 8, so if we square this equality, we will find out that cosine x equals to 49 over 64, so we can substitute cosine x in this equality by 49 over 64. So we substituted cosine square x by 49 over 64, and we found out that sine x equals to root 15 over 8. Okay, then we return to our first equality that states that the area of triangle ABC equals to 56 times sine 3x. And we have trigonometric identity for sine 3x. According to this trigonometric identity, sine 3x equals to 3 sine x minus 4 sine cube x. So we can substitute sine x by this expression that equals to sine 3x. So we found out that the area of triangle ABC equals to 56 times sine 3 times 3 sine x minus 3 sine cube x. Here we took sine x as a common factor of this equality, and we found that the area of triangle ABC equals to 56 times sine x times 3 minus 3 sine square x. So we can substitute sine x in this equality in equation number 1 by root 15 over 8, and we can substitute sine square x by 15 over 64. Okay, and we found out that the area of triangle ABC equals to root 15 times 231 over 16 square units, exactly the same result that we found in the first method. So the area of this triangle ABC equals to root 15 times 231 over 16 square units. Okay, thank you very much.